it's like if you were to slice this, and it's like, what would the slice have the shape of?
Have the shape of a triangle.
Of a triangle, yeah. Sometimes we can actually like get a like a known thing. Like if you cut a, oh boy, like a slice of butter, you get a square
Yeah.
kind of thing. So it it unfortunately like they're not really introducing this concept level. Let's just take a look at another question. We'll see if this one makes more sense. So this is the birthday hat. This is the one that moose or buckets wear on their head when it's their birthday. And do you know what it's called?
A cone.
It's called a cone. Okay. And the cone, uh, it has a base that's a circle M. Do you see that?
Yeah.
All right. So they actually all have circle M. The vertex is J. Let's see. Do they all have that?
And the edges are K and L.
There's actually an edge over here on the right. This is an edge on the right, and then this is an edge on the left. They're both edges.
Oh, so like K and L aren't really like edges.
No,
Or
well, it's a line segment. Line segment JL is an edge, and line segment JK
oh, okay,
is an edge.
that's right.
Although that's not completely true, because if you looked at it, this is because we're looking at it from the side. If you were to look at it from above, you wouldn't see any edges. So I don't know. I'm not sure exactly how to like proceed with this lesson with you, because it's really very difficult to actually do anything conversation wise on this. But this is the stick of butter I was mentioning, and it is a rectangular prism. You probably know that, or could see that. The vertices are all, they're all the points here. These are all the vertices. Vertices are like the sharp edges, if you want to think of them that way.
Okay.
QRS, yeah. All right, and then the I'm just looking at the base here. So the next thing is the edges. I mean, there's a ton of edges. These are all edges. They're all edges. It's got a lot of them.
It does.
And they're all line segments, I guess.
So for the bases, would it be like QR and PS and LM and ON? Because
well, the thing that's not clear to me is the base could actually either be like this square over here or this bottom one. The base is generally the thing that it sits on. So I'm going to say the base is PQRS. I'm just looking at the rectangle lawns. No, that's wrong. PQRM. It's also wrong. L, M, N, O, Q, R, S, P. Yeah. Okay. So the base is generally what it sits on. Like you sit on your butt, that's your base.
yes.
Okay. Let's look at another one here. This is another. It's another prism. Okay. So the vertices are all the points here on the ends. You see that?
Yes.
The edges are all the lines. They're all over the place. And then the base is what it sits on. And that's probably the most distinguishing part. The base is this A, B, E, H. Is that okay?
Right. Yeah.
Okay.
Yeah.
All right. So I think we got that down. All right. So the next two problems, I think these are probably the hardest to do, is it would actually be really a fun, like, in-person project to do, is to figure out like what this folds up into. So the
If
way you might do it is you would have like one group on one side of the room, they would wrap up something,
mm,
and then the other side of the room would get this unfolded, and they'd have to figure out what it actually looks like. So you probably like, and these are hard to do, but like imagine this is the base,
mhm.
okay, and then there's this. See how these kind of come up? They all kind of come up to a point. Sorry, that's drawn really poorly.
Yeah, it's a pyramid.
It's a pyramid. Yeah, yay. It's a rectangular pyramid though, because there's two types.
That's
And
that's right.
and actually this is not a great drawing, because they should somehow indicate that this and this are the same and these are the same, but they're not the same with each other. Okay, so you got that down, great. And then the harder one is what's going on here. I don't know. I actually don't know how visual you are. I mean, I know you did some art stuff a while back, but um,
That's somewhat of like a pyramid, like a rectangular. It's really
so it's got this, and then all of these are trapezoids. Do you see that?
yes.
Okay, so they kind of come up like this. All right, and then this piece over here on the right, it connects the top here.
Yes.
So it's like a pyramid, but with the top cut off.
So what would you call that? Like a trapezoid pyramid, like a rectangular trapezoid pyramid, or
It's because okay, so because there's some congruencies, it's a trapezoidal prism,
okay.
which I wouldn't think you would know how to do. Um, just it's really odd, but we'll go with that. I think that's right. So, okay. And let's see here. Something was missed. Why was that missed? Oh, I didn't choose the right. Oh, it does have no edges. So a cone has no edges. I guess I was not clear enough with the answers with you. But moving along. All right, so let's look at your next lesson here. Hey,
Okay.
they all went pretty fast. Hopefully, uh, next one's pretty visual. All right, so the next question here, in this was a skill that was really important like a million years ago when dinosaurs roamed the earth. Um, Engineers, architects, they used to have to like draw different views of this.
hmm
Now we have 3D printers, we have computer aided design, we have Google. Like we don't like struggle to be like, wow, I wonder what this looks like. But what they're showing you here is, or what they're asking you to do is they're asking you to figure out like what is the view of like a stick view where you can kind of see through the object.
hmm
Okay. And they're asking specifically about the isometric view. Okay. So the isometric view is like let's say this. It's kind of like the angled view, I guess. So there's only one that's sort of even reasonable here. So I'm just going to snip it in. Maybe you can like believe me when I say, oh yeah, this is the
Isometric view.
isometric view. So can you kind of tell me why you think that's the isometric view of this one?
Well, I think it's because it's so from the purple square of purple, red, and green block, you can only see three, but behind it, there's actually fourth block.
Yes,
And
that
you,
it's sitting on, right?
yeah. And with the bottom picture, you can visually see that, oh yeah, it's not, the purple block isn't magically standing, like
It's
magically sitting there.
yeah, it's not just free floating. So, here, let me snip in another isometric view, and maybe you can tell me why that's the isometric view.
Well, another reason is that you can, like, if you remove the color from there, you can also see like, oh yeah, there's another block behind the four blocks.
Mhm.
And so it also visually shows you that, oh yeah, there's not like, because if there wasn't similar block to the other ones, it could have been, I don't know, like a rectangle or a something else, like a different block or something.
Okay, so yeah, that's all really good. So I'm trying to look through these questions. These are really good questions to ask and like understand. It's kind of like when you're working on your car, you're like, oh, that's behind that, but I can't see it. So let's talk about the isometric view. Is this the correct isometric view for
Yes.
this one? Okay. Now, when you look at it from the front, and
Hmm.
like sometimes you need to actually like label what the front is. This is the front.
Hmm.
Does this thing on the left look like the front? If you just
Yes.
looked at the front, yes, that's good. That's good. Now, from the side, and it actually doesn't specify which side. From the side, you can only see that there's an S, an S, and an S. Do you see that?
Hmm.
The top, though, the top, you would just see these two. So,
Yeah.
so the top would actually just look like that.
Yes.
So you see how that's no good?
Hmm.
All right.
Yeah, I was quite confused when they were talking about the top. I thought they were meaning like the red and blue and purple block and not the green block, but that makes more sense now.
There used to be some really good games. One of the earliest games on the PlayStation 4 was one of these sort of like things where you had to figure out whether there was a um, a path to walk on or not. It was based on kind of these views. So is this the correct isometric view on the right for this one?
No.
No. Okay. Now let's see, is this the correct front view?
Yes.
Yeah, I agree. It looks good there. How about from the top?
Yes.
Yes. And how about from the side?
Yes.
I agree. Okay. Unfortunately, there's not a lot of teaching. It's just like yes, no on this. So let's do the same thing for this next one. Maybe we'll get through a few more lessons today than I thought we would. I'm not sure. Probably the next one will be longer. So, all right. Is this the right isometric view on the right?
No.
No. How about from the front? Is that right?
Yes.
That looks good. How about from the top?
Yes.
What about this one right here?
Oh, yeah, that's incorrect.
Shouldn't this be the top?
Yes, that's right.
Okay.
From the side, yes.
Yeah, I agree. So this next one's a little bit tougher like us to do, but if you had grid paper, we'll just do it. We'll just freehand it. But um, first thing they want you to do is draw the top view.
Mhm.
So to me, this is the top view.
Yes.
It's got three right there.
Hmm.
The bottom is next, and the bottom actually looks almost the same as the top.
Hmm.
Like I can visually like rotate this around and like see what it looks like from the bottom of the top.
Yeah, it's like an upside down T.
Yeah. And then the front is looks like this.
Hmm.
Okay. And then the back looks the same.
Yes. And I'm assuming they want the side.
They want the left and the right, and they're both just
Three
looks,
three blocks.
yeah. Okay, so let me see which one is correct. looks pretty good. All right, I think we got all these questions down. I'm just double checking. Hopefully your understanding is better now also because we've gone through it a couple of times.
Yes.
I think this could be a really useful skill for you doing these projections. 'Cause like I said, you may need to like visualize something behind something, or wonder how it's going to work together. So boy, that's a toughie. Let me see what else we got. Euler's formula. Just looking at this one. You actually did okay on this, but we might as well do it. All right. Okay, it says identify the number of vertices,
Mm-hmm.
edges, and faces of the polyhedron. Okay, and the number of let's go vertices. So there's one up here, and then 1, 2, 3, 4, 5, so 6.
Yes.
So vertices is 6. The edges, it's each of these, so that come down. There's 5 that come down. Okay,
Mm-hmm.
but then there's also 5 down here.
So that's 10.
That's 10, and hopefully you can follow. And then faces, there are
There's 5.
There's 5 faces, but
But
they also include the bottom, so that's 6.
yeah, that's what I was gonna ask, if the bottom also counts, but that answers my question.
And then there's this thing called Euler's formula, which he has a lot of formulas because he was kind of an amazing guy. I think, at least in the math sense. F plus V equals E plus 2.
Mm-hmm.
So does 6 plus 6 equal 10 plus 2?
Yes.
It does. Okay, so we're looking for the one that matches that. But 6, 10. They actually do it. Your class does it this way. They go F plus V minus E. Does that equal 2? And it does.
So which one should I use? Should I use the one F plus V equals E plus?
It doesn't matter. You get to
Oh.
choose. Okay, so let's do one more here. Okay, so we'll start with the number of vertices. So you got to like pick a path, but like to me, there's 2, 3, 4, 5, 6. There's vertices of 6, and then edges. So I'm going to start over here like 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I got them all. And the thing is like if you miss one, can't really do much. Faces 1, 2. Then you got the bottom, that's 3, the kind of the front and the back. So I see 5 faces there. So does our formula work? Is F plus V minus E, does that equal 2? 5 plus 6 minus 9. Yes, it does. It'd be so much easier if you could touch this. Like if you could touch it and hold it, you could move it around and you would see them all.
Yeah.
And that, I mean, there's students that just they can't visualize, and there's nothing wrong with they're just not visual. I mean, that's just the way it goes. So all right, so we got those down. That's great. Just looking at some problems here to figure out which one to do next. Okay. this problem is something they show in a third semester calculus course. It's not like the first problem they show, but it's kind of a preview of that. So they have a cube, and cubes, as you know, are every side is the same. Okay. So the way you do this problem is you start with the base,
Yes.
and the base has a 17 and 17.
Yes.
To find the diagonal across the base, use the Pythagorean theorem, a squared plus b squared equals c squared. So in this problem, this is your c squared over here. So c squared equals 17 squared plus 17 squared. Now this is going to violate some things that you've always done, but you actually don't need to find, well, actually, we might as well do it. We will find c. So c is the square root of whatever this number is.
Okay.
But you don't need, you don't want to actually take the square root of it. So 17 squared is 289. 289 doubled is 578.
So
this right here is 578. So the thing running across there is 578.
okay, so
Okay.
don't find the square root.
Don't find the square root. So notice now though, when you go up, okay, like this is also 17, this height here.
Mhm.
And so this diagonal across, which is the square root of 578, there's a height of 17.
Mhm.
Do you see what I've drawn there, those two?
Yeah.
And then the diagonal all the way across from like the upper right to the lower left, this is also a right triangle.
Oh,
Okay, so just kind of believe me for the moment, because we really need to we really need a room to see this. But it's the same thing. It's A, B, and C, and you want to
yes.
find this new C. So you square the square root of 578. So see how it undoes the square root?
So I get 578 plus
89.
289.
Okay, and then you need to take the square root of the sum of those.
Okay, so I do find the square root in this part. Okay, great.
Yeah, well, yeah, yes, the answer is yes.
Let me just write all this down. I get 29.4.
Okay, let me double check you, because that looks like one of the answers that was maybe not right. Just check your square root of, yeah, okay, yeah, that works. All right. Identify the length of its diagonal. We just did that. Okay. So this is a working backwards problem.
Okay.
I don't want to just give you a formula, but so I guess we'll just work it out. So this time they're saying the diagonal of a cube is 20, and what they're referring to, I think, which could be wrong, is they're referring to, let me change the color here. It's always tough because I'm trying to interpret what they're talking about. So they're referring to that, from that corner all the way up to that corner. And if you recall in the last problem, we did this kind of triangle here.
Oh, yeah, the right triangle.
So that's 20. Okay, and that's X.
Okay, so
right. And before, this is X and this is X.
Mhm.
So to get this other side here, it ended up being the square root of X squared plus X squared.
Yes.
So the formula, and this is why I'm kind of like showing you, is the formula is, it's still a squared plus b squared equals c squared, but your a this time is this right here, this square root of X squared plus X squared. Your
So that
b
cancels out.
It does cancel out. Your b is X squared and your c is 20 squared. So it ends up being X squared plus X squared plus X squared equals 20 squared, or 400.
Yes. So 3x squared equals 400. So,
Divide by 3 and then take a square root of both sides.
okay.
Do you have an answer for me?
I have 11.5.
Good. All right. So the last two problems are the same, just different numbers. And this will probably close out our lesson here doing these. So it says a rectangular prism has a base of 19 by 8. So this is 19 and this is 8. See, I'm drawing kind of a square pushed over.
Yes.
And then here's the height. Okay. And when they say diagonal, what they're referring to is the distance from here all the way up to here. Okay. And so what we really need is this a part across the triangle.
Okay.
So this part across the triangle is 19 squared plus 8 squared square rooted. That's the Pythagorean theorem part, right? You square A, you square B, and you square root it.
Yes.
Okay. So notice now that we have a third, a second triangle here.
Mhm.
So it's the square root of 19 squared plus 8 squared squared plus h squared equals 25 squared. That's your A, your B, and your C. So like you mentioned, that this undoes it, this is undone.
Yes.
Okay. So you solve for h squared. So h is 25 squared minus 19 squared minus 8 squared, and then you take the square root of that.
I get 107 as my final answer.
Did you take a square root?
Yes.
I don't think you did, because if you did, because the square root does not undo these. You should not get you should not get a number bigger than the ones we already have.
Um,
I don't think you took a square root as your last step.
probably didn't. Let me.
Now, are you using your calculator on your handheld, or are you going to like a Desmos Scientific?
I use my handheld. I'm going to go to my scientific now because this is just.
Using the right tool makes all the difference.
Okay, I get 14.1.
Okay. And not 14.2. So the rounding is good on that.
14.14. So
Yeah,
there's
that's right. Yeah, you rounded correctly. Okay, perfect. So this one, kind of the same thing here. You know, you don't have to draw it to scale or anything. You just got to draw it 18, 15. This time it has a height here. And what we're trying to find, and this is where the colors really, I think, help is the diagonal. The diagonal is up here, and that's 25. And what we need is this other diagonal down here,
which is 18 squared.
plus 15 squared, square rooted. Yes. So now you can do your official, like the one you need for this problem. You know, your a squared plus b squared equals c squared. Your a is going to be the square root of 18 squared plus 15 squared squared plus, this time it's h squared equals 25 squared. And as you said, the square end is the square root. So your h this time is the square root of 25 squared minus 18 squared. Sorry, I didn't mean to interrupt you.
No, it's okay. Okay, I get 8.7.
Say that one more time.
8.7 as my final answer.
All right, let me just check. There it is. Perfect. All right. So let me see here. All right, great. So that does take us to the end of our lesson for today. I will send you the notes and the screen recording here shortly. Great job as always, and I'll see you next time.
All right, thank you.
Have a great day. Bye now.
Bye.